next speaker is Agboada, and I'll just share the slides also via Zoom so that you can all see them, and then you're free to go.
Thank you very much.
Now.
Thank you very much, Carol, and thank you very much, colleagues from Regensburg, for the invitation. So I'm Desmond, and I'm a postdoc in Munich, in the Federal Armed Forces University, and our group is concerned with TMS as well. But my background is tDCS. So I'll show some applications of TMS, e.g. The talk so far has been so much focused on the method, but here is some little application for you. So, of course, the title is excitability changes induced by another tDCS over the motor and prefrontal cortical areas. So, I don't know if you know about tDCS. Of course, some people don't know, so a little bit of background. So, we know so much about TMS using super threshold magnetic pulses that induces electric field in the brain. For tDCS, we use weak direct current to modulate brain physiology, and obviously the positive electrode and the negative electrode and the anode and the cathode, and depending on the target area you are stimulating, that is either if it's the motor cortex, and that is your target electrode, and this becomes your return electrode. Of course, you need two electrodes for current to flow, and so this is typically maybe another stimulation of the motor cortex. And so in the motor cortex, where this method has been well studied, TMS-induced MEPs have been used as a criterion measure. So when you apply another stimulation using this montage, which was first shown by Nietzsche and Paulos in 2000, where the anode is in the left M1 and then the cathode is in the contralateral supraorbital area. If you use this montage, you will find an enhancement of MEP amplitudes in of course, the motor cortex. And with another stimulation, if you reverse it, you'll find a reduction of the amplitude of the motor cortex, as was shown in this study. But of course, the story is more complicated as the years went by. So it's not just very easy that when you stimulate with another stimulation, you will have an increase in cortical excitability, and then with cathodal is the reverse. So beyond 1 milliampere current intensity in 30 minutes, we see a lot of variability and a lot of differences in what the outcome is. For example, in a current intensity domain, as was shown, I don't know if you can see the picture quite clearly, as was shown back in 2013 by Georgi. So we see that both the 2 milliamperes of cathodal stimulation and 2 milliamperes of anodal stimulation show exactly the same thing. So obviously, something is going on here. We know that anodal stimulation will always show, well, we know that from the basic studies, anodal stimulation will show increase in cortical excitability, but we expect, obviously, cathodal stimulation to show a decrease in cortical excitability. When we increase the current intensity from 1 milliampere to 2 milliamperes, both the anodal and cathodal stimulation are showing exactly the same. They are all showing increase in cortical excitability. Now, in the domain, as was shown in 2017, in the domain of anodal stimulation, stimulating with 0.5, 1, 1.5, or 2 milliamperes of current intensity showed similar results. So there's no linear effect of increasing the current intensity, as was shown over here. We see something similar in the duration domain. So stimulating with 1 milliamperes for 30 minutes, anodal stimulation will show the expected cortical enhancement in cortical excitability. That lasts up to 1 hour after stimulation. However, doubling the duration from 30 minutes to 26 minutes flips the switch. So we don't see the expected anodal clearly cortical excitability enhancement. We see a diminution of cortical excitability. So obviously here, we can already start seeing that increasing in current intensity linearly and the duration linearly does not always lead to a better effect, for example. So I spent most of my PhD trying to optimize the effect of anodal stimulation in the motor cortex. And what I did is that I increased the current intensity from 2 milliamperes to 3 milliamperes. And the stimulation duration also from 15 and 20, which is very common in the literature, to a very longer duration of 30 minutes. And as you can see, of course, we see very nice enhancement in cortical excitability, irrespective of the intensity and the duration. But we did not see an effect of intensity or duration. So significantly, there was no effect between the 3 intensities and the 3 durations. However, what we chose as the most optimal protocol is a protocol that showed the longer cortical excitability or durations up to the next day evening, which is the more intense 3 milliampere for 20 minutes. So that become what we claim to be the optimal protocol in the motor cortex. Now, after finding this optimal protocol in the motor cortex, in this area, we asked our question, so is it possible that if we transfer this optimized protocol from the motor cortex to another part of the brain, we will see similar effects? So that is the whole concept with why we use TMS EEG, to see that can we transfer the protocols we optimize here to the left dorsolateral prefrontal cortex, for example. In this instance, we used our optimized protocol in the motor cortex and compared it to what we say is more like a standard protocol, which is very common in the literature. And of course, the idea is that in the prefrontal cortical areas, a lot of tDCS have been done over there, and there's so much different results so far. It could be that perhaps we are not stimulating the area we should be stimulating that we thought is the area we should stimulate. The stimulation protocols are suboptimal, or the cognitive task is actually not really sensitive enough for the effects that we should see. So there's so much we can think about. Also, of course, this is where a lot of neuropsychiatric disorders are implicated. So it's good we study that with optimal protocols. So we designed this study. This is our first TMS EEG study, and using neuronavigated TMS in the motor cortex and also in the prefrontal cortical area. So there are 6 randomized conditions. So 3 in the motor cortex, the left M1. So the standard protocol of 1 milliampere 15 minutes, the optimized protocol of 3 milliamperes 20 minutes, and then sham in the motor cortex, and the same thing in the prefrontal cortical area. So that is our 6 randomized sessions. As you can see, the electrodes in the prefrontal cortical area and in the motor cortex. And of course, in the motor cortex, we measured MEPs as well. So 130 single pulses, TMS pulses in both locations. And of course, we measured the after effects immediately after tDCS, and then 30 minutes, and then 60 minutes, and then 120 minutes after tDCS. Very simple design, actually. And a little bit of explanation over here is needed, because we initially wanted to have exactly the same stimulation protocols from our previous studies and in our TMS EEG studies. But there is a little caveat or a little problem over here. First of all, in our previous studies, we used a larger electrode, 5 by 7 centimeters, so 35 centimeters squared. But if we have to use that large electrode in our EEG, we would have to take a chunk of the space over here, so we have to sacrifice a lot of electrodes, which we didn't want to do. So we reduced the size of the electrode, so which is now 5 by 5. And by reducing the size, and to be able to get the same current density as we did in the previous studies, we have to reduce the intensity as well. So this, the so-called 1 milliampere becomes 0.7 milliamperes, and the 3 milliamperes become 2.12 milliamperes, so that we get the same current density as our previous studies. And that is the montage, and these are the ROIs for the motor cortex and for the prefrontal cortex. So we have 20 participants and a little bit of the data, which is still very preliminary so far. We have been able to recover a few peaks. An early peak of P30, we saw a good N45, P60, N100, and then P200, and these are the topos in the M1 as well as in the F3. These are what we have been recovered. And so I'll present only the TEPs, and these are still quite preliminary so far, only the TEP peaks. These are the TEP peaks. So we, instead of calling them 1 milliamp per 15 minutes or standard and 3 milliamp per 20 minutes, we just say low and then a high dosage for simplicity. So we see here that we have increased amplitudes for both the low dosage and the high dosage, which are significant when compared to their respective baseline. And these are normalized TP amplitudes. And then, of course, when compared to sham, we see some elevations within at least the first 30 minutes for both the high and the low dosage, which kind of already confirms what we've seen in the previous tDCS literature, that we don't see clear significant differences between the intensities of nodal stimulation. They do similar stuff. So we can see over here. In the prefrontal cortex, which is F3, where our electrode was, another electrode was put, we see quite similar, but only significant differences within the first few minutes after tDCS for both the low and the high dosage. Of course, this early peak, the peak 30, has been shown to be very much related to cortical excitability in the region of stimulation. And so that is how we interpret it, as we are actually stimulating the area that we are stimulating. So the N45, which has been shown already to be associated with GABA A receptors, we see a decrease of that peak, the N45 peak, in both the low and the high dosage for both the motor cortex and then the prefrontal cortical area. And here we see only significances for the high dosage. Of course, we expect that our nodal stimulation would reduce GABAergic transmission in the motor cortex, and as well as, of course, in the prefrontal cortical area. Similarly, we see enhancement in the P60 for both the motor cortex and the prefrontal cortical area. Slightly, we don't know what is going on over here. Some diminution of the TEP peaks, but motor cortex, as expected, we see some enhancements. This is where something interesting is happening. We don't know quite yet fully. We understand that the M100 is also quite associated with, from the Primoli group, is from the TM1 group, sorry, is associated with GABA B receptor activities. But we expect the low dosage and the high dosage to do the same thing. But it seems that here the low dosage is actually increasing N100 TP amplitudes, and the high dosage is decreasing. Even though it is not significant, we see some trend over here, which we expect, of course. And the same thing is happening over here, a little bit of increase in the low dosage, but a decrease in the high dosage, even though obviously this is still not significant. A little bit of trend-wise effect over here, which we fully don't understand quite well so far. And we don't see anything significant going on in the very later peaks with P200. So we also did a correlation between our MEPs that we measured in the M1 and of course our TEP amplitudes, and because they are also of different scales, we first converted them to standard variables, and then we did a standard Pearson correlation, and we, oh, sorry, this is not the correlation, this is just MEPs, sorry. So we measured MEPs, and we saw clearly that both the low dosage and the high dosage showed enhancement in cortical excitability as we expect, and there was no difference between the two another protocols. And I think this was what I was talking about. We did a correlation with our TEP peaks and the tDCS protocols, and we found positive correlations which were significant for the early peak of P30, and then that of P60, and that of N100. We are yet to really have a good explanation for this correlation, but we know that a good correlation with the early peak, which we interpret as being functionally related to the stimulation, means that, of course, there is cortical spinal activity going on, as well as our neurophysiological TEP activity. So we see that we can actually optimize protocols in the motor cortex and transfer them to the prefrontal cortical area. But of course, we don't see a perfect transferability. We don't see everything that we do over here in the motor cortex and the effect we get to be the mirror of that what we see in the prefrontal cortical area. And of course, we see that we have a good enhancement or good modulation of our early peak of P30, which we interpret as being functionally related to the stimulation. And of course, we have some correlation with our MEP in the motor cortex, at least. Yeah. And of course, if you have some questions, so this is our basic setup. So I used Mag and More. Now I'm using MagVenture in Munich. So this was back in Dortmund. So Mag and More, and then the neural navigation is I think the Power Mag neural navigation. This is our setup. The participant sitting, and this we have our mechanical arm, which is not a robot, obviously. And of course, this is the motor cortex stimulation. We use the 5x5 as a span, and we put the 1020 cream on it to stick to the head, and then we put the electrode on it. Yeah. So if you have any more questions, if you have questions, I would be very happy. I think some people have already asked some questions yesterday, but yeah.
So thank you very much.